No.
No, right? Because after the decimal, we have two values and this won't make sense, right? Okay. Double precision is just your traditional floating point double values. Double precision just allows you 53 bits of precision. Floating point just allows you 24 bits of precision. So that works the same as your C++ floating and double values.
Okay.
Remember in C++ we had float data types and double data types
Yep.
and things like that. So double data types, remember, were able to store larger decimal values compared to float decimal values where it had some limitations, but it was still useful, right? So essentially, float and double precision are for those. Numeric data types are where you specify the number of digits after the decimal. So for money, for example, we can have 1 penny, but we cannot have half a penny.
Oh,
That makes sense.
kind of makes sense. Uh, I I still get confused between float and numeric.
Float and numeric. Okay, so float gives you 24 bits of precision and you can have your decimal value anywhere. So you can have 4 digits followed by a decimal point and then other values. It does not care. Float basically maintains that this is the bits of precision that I can give you. Numeric, on the other hand, tells you that these are the total number of digits that I will save, and these are the total number of digits after the decimal point that I will allow. So
Oh,
it is more strict compared to a float,
okay.
right?
Okay. Yep. Thank you.
Any other questions from anybody else? So sometimes some databases also call this double precision as a real data type. So keep that in mind as well. Okay, moving on. Then we have date, time, and timestamp. Very useful data values, and you would, if you are implementing your databases or working with databases, this is what these data types are what you will lose your hair for basically, or make your gray hairs, because dates and times are complicated. Trust me, they are complicated. Even in the US they're complicated because of the different time zones and daylight saving times. And let's say that you want to contact a person from Kansas with a person from India. Imagine the time difference accounting for the daylight savings times as well. And that becomes a huge head scratch. So that is a thing that you need to worry about. But essentially, these are very, very useful tools to have. And then we have these funny looking data types, that is blob, clob, and text. These are usually lobs, essentially large objects, but they're still funny. Blob means binary large object. Clob means character large objects. So essentially, these are used for objects. These are used for your images. So if you want to say that, let's say that we have our account ID, our person name, and an image of the person, or an image of the signature of that person. Right. So for those, we would use a binary image for that particular thing. So we would use a blob. Or let's say that we are maintaining a library database that actually saves the entire copy of that book in a file, in a text file. So that would be a character large object, right? That has meant multiple characters in that same as an attribute. We also have text data types. Usually these are all, so clob and text are used to save character values, but we have also seen char and varchar as our character data types. But remember that these can be limited. Although we can specify the value of n for those variables or those data types, they do have certain limitations. So for example, for MySQL, I remember that char is limited to 256 characters at most. You cannot go above that. And varchar is 64 kilobytes at most. You cannot go above that. So for larger text files, you would rather use the text data type, things like that. Then we have also got special data types such as enumeration. So enumerations are essentially certain flags or certain values for your data types that can get one of certain set of values. So for example, for a bank account, you can say that this bank account is expired or disabled or active. These are the three possible values that your attribute can have. So that would be something of an enumeration. So you can have one of three values, you can not have anything else. So that is what we call enumerations. We also have geospatial data. So geospatial data, as you know, is quite popular these days. People actually want to have map data in their systems. Uber, right? Uber, Domino's, Pizza Hut, pick one, right? Do you want to have a map database that can tell me how far is my nearest Uber car, right? So those would fall under your geospatial data types. And then you can also have your user defined data types as well. And that actually reminds me about an announcement I totally forgot to make. So before I come to this particular thing, should I talk? I'll talk about this after the end of the class. Okay. Basically, just remind me to talk about project stuff, um, like the number of students in a project and things like that. Anybody? Okay. Coming back. What else? So when we are deciding upon a particular data type, we need to understand what data type matches the things that we need to store. So let's say that we are trying to store zip codes as one of our column values. So let's say that usually our zip codes are some particular set of digits. Usually there are 5 digits in the US. So if that is the case, would integer or int make sense to store our zip codes? Yes, no. Don't look at the problems later down the line because my slides are weird. I want your intuition or guesses. Yes.
Technically, yes.
Yes, I have two yeses. And are only two people paying attention? Come on, yes or no? It's not graded. I have four yeses. No, I have two no's, sort of. So Justin and Devon, why would char work better or why won't integer work?
Integers will truncate leading zeros.
Yes, exactly. So if you are from, let's say, in the US, if you are somewhere from the East Coast, uh, I don't know if any of you are, but if you are, then you would know that some of your zip codes will start with zeros. And if they are starting with zeros, then integers won't work. Remember that, for example, 0200, let's say that that is an example, zip code 0200, then that cannot be an integer because 200 is an integer. 0200 won't be an integer, right? So some zip codes have leading zeros, and we cannot have zip codes that start with zero if they are integers. That is the first case. The second scenario could be that certain countries, so if you want to design a database that works across internationally, certain countries do not use numeric zip codes. So for example, I know that UK does not, or the United Kingdom or Great Britain does not use um, all numbers for their zip codes. Some of them use alphanumeric characters for their zip codes. I also know that Australia uses four digits as their zip code, so four numbers for 4-digit values. So different countries have different requirements for their zip codes. So in general, it is better to use characters for our zip codes. And even in the US, if you have characters for your zip codes, we can say that there are 5 characters in our zip codes, and we can use a char 5 or a varchar 5, right? However, certain cases also require us to store more than 5 characters for our zip code. So US mail sometimes use an extended zip code, right? Z plus 4. Z plus 4 usually requires your 5 character zip code plus 4 more characters to identify your correct zip code, because we are running out of zip codes quite fast, right? So essentially, this would mean that we have 9 character zip codes for the US. So we would rather have characters for those particular things. So we can have, for example, characters for zip codes that would allow non-numeric characters like A, B, C, D, all of those things in our zip codes as well. And it also helps us get rid of those leading zeros as well. So yes, uh, yes, Edward, Devon, and Justin, you guys are correct. And you can also have certain constraints on your zip codes in your databases as well. So for example, if it's a US based zip code, you can say that your zip code can either be 5 characters or 9 characters. It cannot be anything other than that, right? Because you cannot have 4 character zip codes and then fill out the rest. We can't do that. Or you can also say that if we are saving our zip codes for all of the world, then we can have a varchar of 20, and that would save all possible zip codes across internationally. However, that means that we need to use varchar because we don't know how many characters are going to be used. So for US, we know that it is either 5 or 9 characters, and we can have a fixed size for those. However, we can't say that it is going to be a fixed size of 20 for all of the world. And that means that if we have, instead of a varchar, if we just had a char 20, that would result in a lot of wasted space. And imagine zip codes space being wasted when we are talking about 7 billion people in the world. Right. So when we are talking about 7 billion people and we are talking about 15 characters on average being wasted, we are actually wasting 15 billion characters or 15 billion bytes across your database. Right. So if we have a database, we need to think about those sort of space saving measures as well. Okay, so floating point representations actually represent all values, blah, blah, blah. So 0.1 is 0.11111, infinitely repeating numbers. Numeric is used for saving monetary values, mainly. Okay, so let's create our old friend database, that is our database account. So what would we do? We would have create table all in caps, account, parenthesis open, account ID being our first attribute name, that has to be character 10. We know that our account ID has to be a fixed size of characters. Usually our account IDs are fixed set of characters. Then our branch name, character 20. So that has a maximum of 20 characters for our branch name. And then we have our balance, that is up to 10 digits before the decimal place and 2 digits after the decimal place. And then we have parenthesis and then semicolon, right? I would have chosen, I know it's my slides, but essentially I would have chosen for branch name, I would have rather chosen varchar instead of char, right? Because different cities would have different sized lengths and it would be more space saving to use varchar. Okay. Any questions so far? So this just creates a new table for us, right? So this is just an empty table that lacks any data whatsoever. So let's now talk about inserting data to our table. So we had account ID, branch name, and balance. So we can use the keyword insert to insert into our account table. So that goes as insert into account values. Then we maintain the same attributes that we have in our table, that is A301, New York, and